Is Jacob allowed to record?
All right. So, this is chapter 9, section 1. This chapter should be easier. I mean, it'll get a little bit confusing at times, but quite honestly, it will a lot less mental effort than chapter 8. All right, so today we're talking about a set or sets, a collection of members or elements. When we have a set of things, we call the different pieces or parts of the sets, we call them members. So, what are the members for the set of a rainbow? What are the members? Grant.
Red, orange, yellow, green, blue, indigo, and violet.
Good. Okay, what are the members of the vowel set for the alphabet? Cynthia. Good. Tell me about the members for the Beatles. Okay.
Paul McCartney, John Lennon.
How do you all not know the jingle? Yeah.
George Harrison and Ringo Starr.
Okay. How do you not know John, Paul, George, and Ringo? John, Paul, George, and Ringo. Okay, if you're listening to this recording, it's time to learn John, Paul, George, and Ringo. Because anyone who knows the Beatles knows it's John, Paul, George, and Ringo. Everybody say John, Paul, George, and Ringo.
John, Paul, George, and Ringo.
Thank you. You must learn that little jingle of the Beatles. Because anytime anybody says to you, who are the Beatles, you say John, Paul, George, and Ringo. Because everybody knows John, Paul, George, and Ringo. Okay.
It's going to be on the recording, though.
Shh. All right. So, an example of a set without members would be a spider with 10 legs. How many spiders are there that have 10 legs? None. So, in that set, we have no members. All right. Operations with sets. Okay, so when we have an intersection, we use this symbol. You should be writing as we're going, not saying wait later. Okay? This is the intersection symbol. This means this is an and statement. Make sure you write that and. And this is the elements that are in common in both sets. So the way we would show this is A intersects B in which way? A intersecting B equals. So what I do is I look at set A. And I notice that there is a 2 in set A, and there's also a 2 in set B. And I put it into braces, and I also have a 4 in set A and a 4 in set B. And are there any other numbers that they have in common in those two sets, set A and set B? So I close my brace, and this is the set of the elements for the intersection of set A and set B. Now, I want you guys to do 2 and 3. If you're at home, pause the recording, do number 2 and 3. All right. So, what is the intersection between B and C? Sam Lee. Okay. And the intersection between A and C? Catherine. 5. There's only one member in that set. Now, when you do number 4, really, A intersecting B is one whole set. Just the intersection of those two. What is the intersection of A and B? Belen.
2 and 4.
2 and 4. A intersecting B is 2 and 4. And then what is the set for C? Urani?
5, 6, 7, 8.
So, really what they want is the intersection of A and B intersecting with set C. Which members intersect, Aiden?
What do you mean?
Where is the intersection between those two sets? Journey? There is no intersection. So, Grant, what would I write?
Null set or
We-
just the brackets with nothing in them, or there's one like circle with the 0.
Right. There's 4 different ways to write that when there's nothing in common. We can use the braces and put nothing inside of it. That means an empty set. We can use the word empty set. We can use the symbol null set. Or we can use the terminology null set. All right, so 4 different ways to write the empty set. The next type of situation is something we call a union. Okay, this is an or statement. It is the combined set of elements from 2 sets with no duplication. So it's the combination of the sets without duplicating anything. So A union, and notice union is like a U. That's how I tell the two apart. I don't have the upside down U memorized, but I know that U stands for union. So, because they're going to mix these up. Sometimes you're going to see the U going this way, and sometimes it'll be like this, and you have to know, are they talking about an intersection or a union? I know that this means union. Okay, that would be element. Okay, so the union of A and B is the combination. So that's going to be 1, 2, 3, 4, 5, 6, 8, 10. I combine them. Do I need to write the 2 and the 4 2 times? No, no duplication. All we want to know is what members are in both groups. 2 is the same in both groups. So why don't you find the union of number 2 and number 3. Pause the recording. So the union of B and C is equal to, somebody I haven't heard from, Alexander.
2, 4, 5, 6, 7, 8, and 10.
Okay. 2, 4, 5, 6, 7, 8, 10. Union of A and C, Joshua. This Josh.
1, 2, 3, 4, 5, 6, 7, 8.
There you go. There you have it. All right. So now I'm going to show you how to use Venn diagrams to describe sets. So in the first set, A, I'm going to list, I think I might just draw my Venn diagram. And, I list all my members. With the ones that are in common, I put them closer to the right side. So, notice I have 2 and 4 because those are pretty close to what's also in B. Now, what does that symbol mean? A for number 1. A what? What does that mean, Jacob?
And, or intersect.
Intersect. So the intersection. So what does that mean to intersect? Nick?
Come together.
Come together. Okay. More specifically. Journey? What? Yeah, but not here. Before, when I gave you a definition, when I said an intersection, what am I looking for?
Something that's common.
Something that's in common in both sets. So for set B, we have 2 and 4. That's already in the circle. And then I have to write 6, 8, and 10. Now, where is the intersection? Where is the intersection, Brent? 2 and 4. And that's the area I would shade. Okay? When I have a union of A and B, I list the members of A. I list the members of B. And what does a union mean? What does the union mean? Mary?
A union is where all the sets of members.
Okay. More specifically, yes.
A combination of
It's a combining both sets. Combination. So what would I shade to show the combination? What? All of it. So the difference here is in the shading. Okay? The shading shows the numbers in the set. So in this set, we would write 2 and 4 for number 1. And in 2, we would write 1, 2, 3, 4, 5, 6, 8, 10. Now, it gets even more, look what number 3 is asking. Draw the Venn diagram to represent A intersecting B intersecting C. What area shows those 3 intersecting? Evan? In the middle. And so what's in that set? The intersection of A, B, and C. Nothing. So what do we write? Null set, empty set. Okay? Now, this one gets tricky. It's the union. I think I do a better job drawing it. And I think especially people that have seen this before. Okay. So first, what does this mean right here? What does that mean? Evan? Right, so it's the union. So I'm going to color that. It's all this area includes this whole set, right? You with me?
Yeah.
Now, I'm going to show you C. Now, they want, here's set C. They want, what does this mean? Here's C is going to be in red. They want the, what does that upside down U mean? What? Intersect. So they want what's in common with C and the yellow. The set that's the yellow, the combination. Here's C. So Grant, where is the intersection?
Between C, A, and B, it's in the top right of C and then the top right of top left.
List the members that are the intersection.
Yeah.
What are they?
5, 6, and 8.
5, 6, and 8. Do you see that, guys? So the first one, be careful with your wording there, Grant, because it's not the intersection of all 3. Because this,
No, I know, but I didn't mean the middle. I just meant on
the
left.
intersection of the union and set C,
Yeah, so I meant.
is 5, 6, and 8. Does that make sense, guys? Huh? Is that confusing? It can be, yeah. But do you see the area of the overlap? That's the intersection. We're going to be actually, I think, for our 8th graders that have seen this before, does that make sense to you, more sense to you when I do the double shading? because we use that when we're graphing inequalities, double shading, which is coming at the end of this section. So, Venn diagram can be. I wanted to introduce this to you. You won't have this in your homework, but this may come up with your Common Core testing. So this is one more diagram that would enable you to show the math. Okay? All right, we're going to skip this and go on to Chapter 4. We were able to graph on the number line all real numbers greater than -4. So how would I show that? Urani?
An unfilled circle and -4 going to the right.
Okay, we're starting at -4. It's an open circle, and we're heading to the right. So I'll review of chapter 4. When it says all real numbers less than or equal to 1. Carlos?
Make a solid circle on 1.
Starting at 1, in what direction?
Left.
Good. Now, look at this one. This is new. All real numbers between -2 and +3. All real numbers between -2 and +3. Let's go, Alex.
So you put an unfilled circle at -2,
Good.
and then you go until 3, and then put another unfilled circle.
That's right. An unfilled circle at -2, an unfilled circle at +3. Because it doesn't include them, it's only between, and I draw the line. All numbers between -2 and +3. That way it includes all the decimals, the fractional amounts, but not -2 and not -3, +3. Okay?
-3 either, so.
Right. But in this case, the set of members is everything from -2, but not including -2, up to 3, and not including +3. Okay? Can I move on? Okay, now, Setbuilder Notation. This is where you will need to know your vocabulary inside and out. When I teach my 7th grade, I show them a slide, and it kind of looks like this. It talks about you've got to know these definitions. And when we look at our number system, because last period a girl asked, what do you mean real numbers? Are there fake numbers? Yes, there are. So, the first thing we're talking about are our natural numbers. These are all of our counting numbers. 1, 2, 3. Okay? Okay, so all of the counting numbers. Then we move on, we go to whole numbers. How are whole numbers different than naturals? Urani?
They include negatives.
Nope. Grant?
Zero.
They include 0. A whole number starts at, in that number set, it starts at 0, and it goes on and on forever with all the with all the natural counting numbers. So whole numbers include natural numbers, but they also have 0 in their set. The next group is integers. What's an integer? Urani.
These include negative numbers.
These include all the whole numbers, 0, 1, 2, 3, and their opposites, all the negatives. So +3, -3, 0, -2. So integers include all of these. Then we have rationals. Rational number, the true definition is any number that can be written as a ratio between two numbers. And that is the fancy way to say what, Grant?
Fancy way to say a fraction or
Right.
decimal amount.
Yeah, any number that can be written as a fraction. A ratio between two numbers is really a fraction, so that would include can we write a repeating decimal as a fraction? Yeah, 1/3, right? There we go. So all repeating decimals, all fractions, all negative fractions, all mixed numbers, whole numbers. These are also rational. Everything rational includes all integers, wholes, and naturals. So do you understand how all the other sets are included in the rational set? Now, outside of that, you've got your irrationals.
It's pi.
That's pi. That's the square root of 6, the square root of 7, the square root of 8.
But they're still real.
Okay, hold on. Irrational are all the non-perfect squares. Square root of 9 is 3. Can 3 be written as a fraction? Okay, so you've got irrational and rational. And together, those two make up the real number system. And so when I mention that, it says all real numbers. Okay, and outside here you have these imaginary numbers. Square roots of negatives. As opposed to the real number system.
Are square roots of negatives the only thing?
Let's just stick to this because we're going on. We got a lot more to do, and I'm running out of time. Can I erase this?
Yes.
Okay, you got to know these definitions. This chapter will depend on it. If you don't know the constraints of these words, then you will get problems wrong. So with set builder notation, you've got roster notation and set builder notation. Roster notation is what we've been doing. We list the numbers in the set. That's roster notation. Set builder notation, we explain the rule. And we read it, X is such that X is. Can you read that with me? X is such that X is a natural number and X is less than or equal to 5. All they're doing, it's fancy writing. Don't worry about it. You're just really writing the rule of what's happening. X is such that X is. You're always writing that. And then, remember, these are all of our natural numbers. But what this rule does is it gives you a top and a bottom within that set. By stating that it's a natural number, it's showing you the natural numbers start at 1. It gives you a starting point right here. By saying that X is less than or equal to 5, it tells you the highest point in the set. So do you understand? You could even say that in words. You don't have to say it with that symbols. With the symbols X is less than or equal to 5. Okay, so now, how would I write this one in set builder notation? And because the set is called B, we'll say B equals, and then how would I read it? What do you think? Kelly, why don't you give it a try?
X is a natural number.
X is such that X is a...
X is a natural number and is between 4 and 7.
Good. She could write it in words just like that. What you just said was perfect. I could also write it like this. I have 3 ways I could write this. And X is greater than or equal to 4. And X is less than or equal to 7. Close parentheses. Close braces. I could also have written this as what's called an in-between statement. Put X here. X is bigger than or equal to what number? What is X bigger than or equal to? Aria? 4. And x is smaller than or equal to what number? Urani?
7.
And that's how my PowerPoint does it. That's this whole thing. These two are replaceable. Can I erase?
Yes.
And I'm going to show it to you with my PowerPoint. Notice how they do it. And 4 is smaller than or equal to x, which is smaller than or equal to 7. We call that an in-between statement. Okay, questions? Roster notation is what? Restate that again. What is roster notation? Aiden.
Writing the numbers in the set.
Just writing the numbers in the set. Good. Now, if I'm doing that in roster notation for A intersecting B, what do we get? Aria, what is in roster notation? What is the intersection?
4 and 5.
4 and 5. Good. So remember, intersection is what's in common. Union, U, is what? Kelly?
Oh, wait. 1, 2, 3, 4, 5, 6.
1, 2, 3, 4, 5, 6, 7. And that is the combination. It's the combination. Okay. Okay. So if I'm going to set builder notation, here's how it's going to look. Now it says, now this is a very important part of it. The thing I want you to make sure and pay attention to is notice they're telling you they want A to be roster notation. So you have to list the roster. Don't go listing your roster notation here or I'd mark it wrong. Do you understand? Don't mark B as your roster notation. Okay, so whole numbers, X, now this new symbol is called element. Okay? It says state the domain of X in A, roster notation, and B, set builder notation. So what this is saying is, what are the elements that X is allowed to be? X can be a whole number and is less than 5. So for roster notation A, what am I listing? Nick?
0, 1, 2, 3, 4.
Whole number tells me my starting point, 0, and less than 5 tells me my end point, up to 4. Okay? The E is an element, also means member. What are the elements? What is the members? Now, how would I write that in set builder notation? Grant?
X is such that X is a whole number for less than 5.
And X is...
Wait, and X is an element?
No, you were right. You just didn't put the word and in there.
Oh,
Okay, one more time. X is such that...
X is such that X is a whole number and less than 5.
And
Is
X is less than 5.
Yeah.
Okay? Now notice, if you... Get your eyes up here really quick. If you just wrote this whole thing in here, if you just wrote that whole thing in there, after X is such that X is a whole number and is less than 5, that would be correct. Or, instead of writing X is less than 5, you can write this. To me, that's easier. I don't want to write more words. That's why I got into math. Okay? Number 2. Roster notation, please. Somebody I haven't heard from. Roster notation. Evan. Good. And notice it says between, so it doesn't include -3 and 2. Okay, Byron, you want to give Setbuilder a try? Brent, you want to try it? Try it. X, we all know the beginning. X is, and, okay, so he said, okay, how can I write that mathematically, Cynthia? X is such that X is an integer, and how can I use my inequalities to describe it? Aria? And? Perfect. Or I could write it as the in-between statement. What you just said was okay. Remember, I can always write this. This is just 2 statements. Look, I'm going to block it with my hand. Do you see that? That's one statement. And this is another statement. You guys seeing that? It's just 2 statements written as one. Josh. Sure. You want to do, why don't you do the set builder? Let's first do, I want to call somebody else for roster notation. Dixie, give me roster. That's it. 1 through 7. 1, 2, 3, 4, 5, 6, 7. And now Josh is going to give me set builder notation.
So x is such that x is a natural and x is less than 7.
Perfect. Beautiful. So 3 different ways to write that set builder notation. Okay, questions? All right, it's a long video, so stop the recording.